y equals x to the cosine of x is an example of a function that we have not yet seen how to differentiate. We may think, well, it's x to the cosine of x, so I can use the power rule. Nope. Power rule works when the exponent is a constant. Here I have a variable base and a variable exponent. The way we're going to approach this, logarithmic differentiation. Apply the natural log to both sides. So we have the natural log of y is equal to the natural log of x to the cosine of x. Using a property of logs, the cosine of x exponent can come out front as a coefficient. So the natural log of y is equal to the cosine of x times the natural log of x. At this point, what I'd like you to do is pause the video, differentiate on the left and the right hand sides using whatever tools you know you need to use, and come back when you have isolated y prime. Those tools on the left would mean implicit differentiation, and on the right it would mean the product rule. So on the left we have 1 over y prime, and on the right, identifying the cosine of x as u and the natural log of x as v, we have u prime v plus uv prime is equal to negative sine of x natural log of x plus the cosine of x over x. Y prime is then equal to y times, and I rearranged the order of the terms so I didn't have a leading negative, y times cosine of x over x minus sine of x times the natural log of x. Remembering that y started out as the expression x times the cosine of x, we get that y is equal to x to the cosine of x times the quantity of cosine of x over x minus sine of x times the natural log of x. Again, a terrible looking result, but this is the only way to have done it, and we're never going to make that result look any prettier. So when do we know to use logarithmic differentiation? Logarithmic differentiation is indicated when using properties of logarithms will simplify an expression or simplify the differentiation. And then what we just saw is if we have a variable base with a variable exponent, then we're going to want to apply logs to both sides. The process is what I just said: apply the natural log to both sides, use properties of logs, differentiate with respect to x. Don't forget implicit differentiation for the side with y, and then give either dy dx or y prime in terms of x, or whatever the independent variable is. But that means don't give an answer that has a y in it. I mean, y prime equals, right? But on the right-hand side, we have to back substitute. Now, to put that in contrast with other things that we've seen, if we have a variable base with a constant exponent, then we just use the power rule. An example of that would be like x squared. That you would have seen in first semester calculus. If we have a constant base with a variable exponent, then we use our rules for differentiating an exponential. And examples of that would be like e to the x or 2 to the x. And that would be from this course.